Look up at the night sky. For as long as human beings have had the capacity to wonder, we have stared at those distant points of light and imagined sailing across the cosmic ocean to reach them. Our stories and movies make it seem inevitable. We imagine building massive starships, engaging a warp drive, and casually hopping from one star system to another, as if we were just taking a long drive across the country. It feels like our ultimate destiny. But what if I told you that the universe has set up barriers so profound, so deeply woven into the fundamental fabric of space and time, that leaving our stellar neighborhood might remain forever beyond our grasp? I am not talking about a temporary lack of funding or a need for slightly better rocket fuel. I am talking about the uncompromising laws of physics. We are going to confront a harsh reality today. The immense distance between the stars is not just an engineering hurdle. It is a profound feature of the cosmos that aggressively isolates us. Before we strip away the science fiction and examine the hard physics of this cosmic quarantine, if you want to understand the true unvarnished rules that govern our universe, make sure you subscribe to Brian Greene Theory right now. We do not gloss over the hard truths here. We face them directly today. We are going to break down exactly why traversing the dark voids of space is a nightmare of physics. We will explore the absolute speed limit of reality, the staggering energy requirements that break our current understanding of mechanics, and the microscopic violence of the interstellar medium. The dream of reaching the stars is beautiful, but the reality is a brutal lesson in cosmic isolation. Let us explore why the stars are so fiercely out of reach. Think about the longest journey you have ever taken. Perhaps it was a long flight across an ocean or a road trip, driving for days on a seemingly endless highway. When you look out the window of a car moving at 100 kilometers, the trees and buildings blur by. You feel a sense of immense speed, of covering vast amounts of ground. In our everyday human experience, the Earth feels massive, but to understand why the stars are securely locked away from us, we first have to fundamentally shatter your perception of distance. We have to completely recalibrate what the word far actually means. Let us start with our closest neighbor. The moon is about 384,000 kilometers away. If you could drive your car straight up into the sky at highway speeds, never stopping for gas or sleep, it would take you roughly 6 months of continuous driving just to get there. Now consider the sun. It is 150 million kilometers away. That exact same car ride would take you over 170 years. You would need a human lifetime twice over just to reach the glowing sense center of our own tiny cosmic backyard. But even these distances, which stretch our intuitive imaginations to the breaking point, are microscopic. They are almost laughable when we look outward to the rest of the galaxy. To even begin talking about interstellar travel, we have to talk about the ultimate speed limit of reality. In our universe, nothing can travel faster than the speed of light in a vacuum. That speed is roughly 300,000 kilometers per second second. It is a velocity so extreme that a beam of light could circle the equator of the Earth 7 and 12 times in a single second. It is the absolute cap, the unbreakable law written into the very DNA of space and time. Now, let us point our imaginary spacecraft toward the very closest star to our solar system, a small red dwarf called Proxima Centauri. It sits at a distance of about 4.4 light years away. What does that actually mean? It means that if you were traveling at the absolute maximum speed the universe allows, if you were literally riding a beam of light at 300,000 kilometers per second, it would still take you over 4 years just to arrive. But here is the crushing reality of our physical situation. We cannot travel anywhere near the speed of light. We are not even close. Let us look at the fastest machines human beings have ever built. The Voyager 1 spacecraft launched decades ago is hurtling away from us into the dark at roughly 17 kilometers per second. That is incredibly fast by human standards. It is over 60,000 kilometers per hour. A bullet fired from a high-powered rifle is practically standing still compared to Voyager. But if Voyager 1 were aimed perfectly at Proxima Centauri, how long would it take to cover those 4.4 light years? It would take over 73,000 years. I want you to really sit with that number for a moment. 73,000 years ago, human beings were just beginning to migrate out of Africa. The last ice age was still raging across the planet. We were huddled around fires and caves, painting animals on the stone walls. If our distant ancestors had somehow launched Voyager 1 back then, it would just be arriving at the nearest star today. And remember, that is just to the absolute closest star. Our Milky Way galaxy alone is 100,000 light years across. This is the foundation of our problem. The space between the stars is not just empty. It is unfathomably, violently vast. We are marooned on a tiny island of rock in an ocean so wide that our fastest ships are little more than driftwood floating on the cosmic tide. We are trapped by the sheer unyielding scale of the void. You might think then that all we need is a better engine, a more powerful rocket to push us faster. But as we are about to see, the universe does not just make distance a problem. It weaponizes the very act of moving fast. Distance is only the first wall of our prison. Let us say we refuse to accept the 73,000-year journey. We are a clever species. We build immense skyscrapers. We split the atom. We engineer marvels. Surely the solution is simply a matter of engineering. We just need to build a larger engine, harness a more potent fuel, and push our spaceship until it is traveling at 99% of the speed of light. If we do that, we can reach the nearest stars in a few years, not millennia. It sounds entirely logical. In our everyday lives, if you want to go faster on the highway, you press the gas pedal harder. You burn more fuel, the engine works harder, and your speed increases. But the cosmos does not work like a human highway. When you try to force an object to move at a significant fraction of the ultimate speed limit, a bizarre and terrifying rule of nature takes over. The universe actively resists you. Over a century ago, Albert Einstein realized a profound truth about how our universe operates. He discovered that energy and mass are not two completely different things. They are two sides of the exact same coin. They are interchangeable. You have likely heard the famous equation, but I want you to feel what it actually means. E is equal to mc squared, or energy equals mass times the speed of light squared. What this fundamental law tells us is deeply unsettling for our dreams of star travel. When you accelerate a spaceship, you are pumping energy of motion or kinetic energy into it. But because energy and mass are fundamentally equivalent, the energy you put to making the ship go faster actually translates into increased inertia. In practical terms, the faster the ship moves, the heavier and more fiercely difficult to push it becomes. Think of it like this. Imagine you are pushing a small car across a flat parking lot. With a good strong heave, you can get it rolling. Now imagine that as the car rolls faster, it transforms. At 10 kilometers per hour, it becomes as heavy as a semi-truck. At 50 kilometers per hour, it becomes as heavy as a skyscraper. And as you try to push it to 99% of the speed of light, that small car becomes as incredibly massive as an entire planet. How hard would you have to push to accelerate a planet? This is exactly what happens to our starship. At the speeds we need to cross the interstellar void in a human lifetime, the ship gains so much relativistic mass that accelerating it even a tiny bit further requires an incomprehensible amount of energy. To push a ship the size of a modern space shuttle to just half the speed of light would require more energy than the entire human race currently consumes in several decades. And how do you carry that energy? You need fuel, but fuel has mass. If you load your ship with thousands of tons of an antimatter or fusion fuel to reach these incredible speeds, you now have to accelerate the fuel itself. To push the fuel, you need more fuel. This creates a vicious, inescapable cycle known to physicists as the tyranny of the rocket equation. It is a mathematical trap. By the time you calculate the fuel needed to accelerate a massive starship to nearly the speed of light, and then the fuel needed to safely slow it down when you arrive, the required mass of your rocket becomes larger than the moon itself. We are not just fighting vast distances, we are fighting the very fabric of space and time. The faster we try to escape our isolation, the more fiercely the universe drags us down, turning our own speed into our greatest obstacle. We are trapped by the weight of our own motion. But let us imagine that by some miracle of future physics, we somehow bypass this. Imagine we learn how to harness the energy of an entire star to push our ship without carrying fuel. If we solved the energy problem, we would immediately slam into a third, a far more violent wall. Space, you see, is not actually empty. And when you move fast enough, the invisible dust of the cosmos becomes a weapon of mass destruction. Listen closely. We often think of space as a perfect empty vacuum, a serene quiet dark, but I need you to completely abandon that comforting thought. The space between the stars is actually a minefield. It is filled with stray atoms of hydrogen, microscopic grains of dust, and tiny fragments of rock. When you are moving at the slow-crawling speeds of our current spacecraft, this dust is harmless. It gently pings against the hull. But remember, we are trying to travel at nearly the speed of light. And here we encounter a terrifying paradox of motion. The faster you travel to defeat the vastness of space, the more lethal that seemingly empty space becomes. Velocity weaponizes the microscopic. Imagine a single grain of sand. If I toss it at you, you barely feel it. But if that exact same grain of sand strikes your starship when you are traveling at 99% of the speed of light, the relative kinetic energy is apocalyptic. That tiny speck of dust strikes with the explosive force of a small nuclear bomb. Now imagine flying through a continuous blizzard of these invisible bombs. Furthermore, the scattered hydrogen atoms floating in the void are no longer just thin gas. At those extreme speeds, they slam into your ship like a blinding beam of deadly high-energy radiation. To survive, you would need armor plating several meters thick, perhaps made of solid lead or ice. But remember our previous problem, armor adds massive weight. Weight requires exponential amounts of energy and fuel to accelerate. The universe traps us in a vicious paradox. To go fast, you must be incredibly light. To survive going fast, you must be incredibly heavy. But let us push past this. I want you to imagine we solve this problem too. We create some kind of magical magnetic deflector shield. We are protected, fully fueled, free and hurtling toward a distant star system at 99.9% of the speed of light. We have beaten the distance. We have beaten the deadly dust. Have we finally conquered the stars? No, because here we run headfirst into the most heartbreaking paradox of all. This is the moment where the everyday reality you trust completely falls apart. We all share a deeply ingrained belief that time is an absolute metronome. We believe that a second ticking by for me is the exact same second ticking by for you, no matter where we are in the cosmos. But Albert Einstein proved that this is a cosmic illusion. Space and time are not separate things. They are woven together into a single flexible fabric called space-time. The fundamental rule of this fabric is this: the faster you move through space, the slower you must move through time. Imagine I am standing on Earth and you are on that speeding starship. As you accelerate closer snorts to the absolute speed limit, your onboard clocks, your biology, your very heartbeat all begin to slow down relative to me. You do not feel it to you. Time feels perfectly normal. You pour a cup of coffee, you read a book, the seconds tick by exactly as they always have. But if I could somehow look through a massive telescope and see you inside your ship, I would see you moving in extreme frozen slow motion. Let us say your destination is a star system 500 light years away. At your incredible speed, the journey feels like it only takes a few years to you. You arrive, explore an alien world, and turn around to come home. To you, the entire round trip has taken perhaps 10 years. You have barely aged. But when you land your ship back on Earth and open the door, the world you knew is entirely gone. While 10 years pass for you, over 1,000 years have passed on Earth. Your family, your friends, the entire civilization you left behind are ancient history. The cities are different. Everything you loved has turned to dust. This is the ultimate tragic paradox of interstellar travel. The only way to survive the crushing distance of space is to travel fast. But traveling fast disconnects you from the flow of human time. If you leave, you can never truly come back. You become a ghost, permanently exiled from the era you set out to represent. So you are stubborn. I appreciate that. I am too. You look at the devastating impossibilities of accelerating through space, the deadly dust, the heartbreak of time dilation, and you say to me, fine, if moving through space is a trap, I will not move through space. I will bend it. You have seen the science fiction movies. You want to build a warp drive. And here's the fascinating thing. The equations of general relativity actually allow for this concept. The fabric of the universe space-time is not a rigid empty box. It is flexible. It can warp, bend, stretch, and compress. We know for a fact that space itself can expand faster than the speed of light. The very early universe did exactly this in the moments following the Big Bang. So the theory goes, why not build a ship that manipulates this fabric? Imagine a spacecraft that violently compresses the space immediately in front of it and rapidly expands the space immediately behind it. The ship itself would not actually move through space. It would sit perfectly still inside a little isolated pocket of normal space while the pocket itself surfs across the cosmos, riding a wave of distorted reality. You are not breaking the universal speed limit because locally inside your bubble you are not moving at all. Space is doing the moving for you. It sounds like the perfect loophole. But nature utterly hates a loophole. To warp space in this specific unnatural way, you need a material that bends gravity backward. You need something called negative energy or exotic matter. Imagine holding a heavy iron weight in your hand. You open your fingers and instead of plummeting to the floor, the weight violently accelerates straight up and smashes into the ceiling. Is possessed anti-gravity. We have absolutely no proof that this kind of matter exists anywhere in nature. And even if we could synthesize it, the mathematics tell us that to create a warp bubble just large enough to hold a small passenger ship, you might need a mass of exotic matter equivalent to the entire planet Jupiter. But I promise to break your brain. So let us go much further. Let us pretend we somehow harvest Jupiter. Let us pretend we successfully build the warp drive. Here is the exact moment where the universe takes your human intuition, your very sense of logic, and snaps it in half. If you possess a machine that can travel from one point in the universe to another faster than a beam of light can make the journey, you do not just have a very fast spaceship. You have built a time machine. In the deep mathematics of relativity, faster than light travel and backward time travel are the exact same thing. They are completely indistinguishable. Think about what that actually means. Imagine we are on Earth and we witness a distant star explode in a spectacular supernova. That light took 1,000 years to reach our telescopes. The event is already deep in the past. But with your warp drive, you can trace the light. You can surf your bubble of space-time and arrive at that star system instantly. Because you arrive faster than the speed of light, you have stepped entirely outside the bounds of linear time. Depending on how you maneuver your warp bubble, you could arrive at that star hundreds of years before it ever explodes. You could, in theory, interfere and prevent the explosion from happening. But wait, we already saw it explode on Earth. The light has already hit our eyes. If you go back and stop the star from dying, where did the light we saw come from? This is not just a clever philosophical puzzle. It is a catastrophic breakdown of reality. It destroys causality. Causality is the unbreakable chain of cause and effect. I drop a glass, it shatters on the floor. The cause always comes before the effect. But if you have a warp drive, you can fire a laser at a target, warp to the target's location, and arrive before you ever pulled the trigger. You could send a message back to yourself telling you not to shoot. But if you never shoot, why did the target get destroyed? If cause and effect can be shattered, the universe simply cannot function. The fundamental logic of existence unravels. You could be born before your parents meet. This leads many physicists to believe that the universe has a built-in aggressive defense mechanism. It ruthlessly forbids any shortcut, any wormhole, any warp drive specifically to protect the timeline. The speed limit of light is not just a cosmic speed bump. It is the absolute glue that holds reality and logic together. When you try to cheat the distance, you threaten to unravel existence itself. We must now face the hard truth. I have taken you to the very edge of human imagination. We have pushed past the absolute speed limit. We have tried to surf the fabric of space-time, and we have slammed headfirst into the paradox of time itself. Now we must return to the cold, undeniable reality of our physical universe. We are not merely isolated by the unimaginable distances of space. We are actively, aggressively being quarantined by the cosmos itself. You see, even if you accept that a journey to the nearest star will take tens of thousands of years, you might still find a small shred of comfort in that. You might think that we have all the time in the world. You might believe that eventually, perhaps in 1,000,000 years, human ingenuity will find a way to slowly hop from star to star until we conquer the galaxy. But I have to strip that final comfort away from you right now. The universe is not a static, quiet stage waiting patiently for us to explore it. It is running away from us. About 100 years ago, we realized that the universe is expanding. The space between distant galaxies is constantly stretching. But the truly terrifying reality, the hard truth that we only discovered in the late 1990s, is that this expansion is not slowing down as gravity pulls things together. It is violently accelerating. An invisible repulsive force that we call dark energy is actively tearing the fabric of the cosmos apart. I want you to picture yourself on a small raft in the middle of a vast ocean. Now imagine that the water itself is somehow magically multiplying. The space between you and a distant island is literally creating more space. If you look at an island that is close to you, it seems to be drifting away slowly. But if you look at an island that is very far away, there is so much water multiplying between you and it that the island appears to be racing away at blinding speed. This is exactly what is happening to our universe. The galaxies are not simply moving through space. The very space between us and them is expanding. And here is where the laws of physics become utterly merciless. Because this expansion is accelerating, the most distant galaxies are receding from us faster than the absolute speed limit. They are moving away faster than the speed of light. Now wait, I just told you earlier that absolutely nothing can move faster than light. That is entirely true for objects moving through space. But space itself has no such speed limit. The fabric of nothingness can stretch and multiply at whatever speed it wants to. What does this mean for our dreams of interstellar travel? It means that the universe has drawn a hard physical boundary around our local neighborhood. We call it the cosmological horizon. It is an absolute edge of reachability. If a galaxy is pushed beyond that horizon by dark energy, the space between us and them is expanding faster than a beam of light can ever travel. If you pointed the most advanced light-year ship we could ever theoretically build at a galaxy beyond that horizon and you launched it today, you would never ever reach it. You would be exactly like a swimmer trying to reach the shore against a rushing river current that is simply too strong. The water is pushing you backward much faster than you can ever swim forward. You could swim for an eternity with infinite energy, and the shore would only get further and further away. This is the hardest truth of our existence. We are not just temporarily grounded because we lack the technology. The universe is actively locking the doors. Every single second you listen to my voice, thousands of stars cross that invisible threshold, slipping beyond our cosmological horizon forever. They are gone. The light they are emitting right now will never ever reach our eyes. No signal, no ship, no thought will ever bridge that gap. We are permanently, irreversibly severed from the vast majority of the cosmos. We look up at a magnificent night sky filled with billions of galaxies. But the brutal reality of physics dictates that 94% of the galaxies in the observable universe are already forever out of our reach. We are looking at ghosts. We are looking at a mirage of a universe that has already locked us out in the dark. We have stared into the abyss of the cosmic speed limit. We have seen how energy transforms into crushing mass, how the microscopic dust of space becomes a barrage of atomic bombs, and how bending the fabric of space-time threatens to destroy the very logic of cause and effect. Finally, we watched helplessly as dark energy actively pulls the rest of the universe away from us, locking the doors to the greater cosmos forever. You might feel a profound sense of claustrophobia right now, a deep, unsettling cosmic loneliness if the vast majority of the universe is already physically beyond our reach. And if venturing even to our closest neighboring star demands an impossible amount of energy and the sacrifice of our connection to human time, what are we left with? Are we simply prisoners stranded in a tiny corner of a dark, expanding void? I want you to look at this reality completely differently. We are not prisoners. We are the fortunate survivors on a miraculously protected island. Think deeply about why these unyielding rules exist. The absolute speed limit of light, 300,000 kilometers per second, might seem like a frustrating barrier to our dreams of stellar empires. But it is actually the fundamental cosmic glue that allows reality to function. If there were no absolute speed limit, if cause and effect could be scrambled by moving instantly from one star to another, the universe would descend into an unpredictable, chaotic soup. The delicate processes of chemistry, the slow, methodical evolution of biology, the steady burning of stars, all rely on the strict, orderly unfolding of time. The very laws of physics that trap us in this solar system are the exact same laws that allow us to exist in the first place. This cosmic quarantine is precisely what makes the structure of your life possible. Before I share my final realization about what our ultimate destiny truly is in this isolated universe, I want to ask for your direct support. Crafting these deep dives, breaking down the raw mathematical truths of the cosmos without the illusions of science fiction, it takes an immense amount of dedication and resources. If this journey has fundamentally shifted your perspective, if it has made you look at the night sky differently, please consider supporting my work by using the Super Thanks button below. Your contribution allows us to keep pushing into the unknown, peeling back the layers of reality together. We must accept a humbling truth. We may never build grand armadas of starships. We may never physically walk on the soil of planets in the Andromeda galaxy. But that does not mean our era of exploration is over. It just means we have been imagining the wrong kind of vehicle. Our ultimate starship is not made of titanium, and it is not powered by antimatter. It is the human mind through the rigorous language of mathematics, the ingenuity of our space telescopes, and the brilliant deductions of physics. We have already traveled further than any physical ship ever could. We sit on a tiny rock orbiting a painfully average star, and yet our minds have reached back to the violent, fiery birth of reality itself. We have measured the invisible dark energy tearing the cosmos apart. We have mapped the invisible ripples of gravity from black holes colliding billions of light years away. We cannot physically sail the vast, expanding cosmic ocean, but we have already figured out how to read its deepest, darkest secrets. We are physically bound to this tiny, fragile island,